Hi friends, in this video we're going to learn about time variant and time invariant systems. In the previous video we have already learned about linear systems. So continuation to that video, in this video we're going to learn about time invariant systems. So a system is said to be a time invariant system if its output does not depend explicitly on time. That means if we consider an example, like if we consider y of t as the output and x of t is the input signal, whenever we apply a transformation or whenever we shift input by t time units, even the output should shift by t time units. Then such type of system is called linear time invariant system. If this is not satisfied, then it is called linear time variant systems. Okay. Now in discrete case we have y of n be the output, x of n be the input. Then if we shift the signal x of n by k time units, it should be equal to the output. That means even though we change the time samples by k time input by k samples, then the output should be changed by k time samples. Okay. Now we'll consider an example of y of n is equal to x of minus n. Now here, whenever we apply a signal x of n, what is the, in the given question, what is the main theme is we are reversing the time. That means x of minus n. So the operation we are doing here is time reversal. Now when we transform this to reversal, we get y of n equal to x of minus n. Now we will shift the signal by k time units. We will shift the same signal by k time units. We get, already we have x of minus n, so y of, so here we get x of minus n minus k. Let this be first equation. Now we apply the transformation of y of n minus k directly to this signal. It becomes x of, in place of n we need to substitute n minus k, minus of n minus k. This will be x of minus n plus k. This is 2. Now if we see equation 1 and equation 2, both are not at all equal. 1 is not equal to 2. So it is time variant system. This time variant system. That means when we apply the transformation, we get the output as 1. When we shifted the output signal by k time units, we got the equation 2. For a system to be linear system, both should be matched, both should be equal. But here in this case, it is there, both are not equal. So it is a linear time variant system. Now let me consider other example. Y of n is equal to cos 2 pi n times x of n. This is the given question. You are asking whether it is a time variant or time invariant. Now if you see in this expression, the only operation they are doing is they are multiplying cos 2 pi n to x of n to get y of n equal to x of n cos 2 pi n. Now I will shift the signal, or I will apply the transformation of by k time units, then it becomes x of n minus k cos 2 pi n. We not bothered about cos 2 pi n because here this acts as an amplitude. We are only shifting the time. So whenever we shift the time, only time should be shifted. So time will be in the brackets and this is the amplitude. So amplitude will not be changed. Now whenever we apply the transformation y of n minus k, it will be, now here in this case we replace n by n minus k. This is the second equation, this is the first equation. So if you can clearly see, 1 is not equal to 2. So even this is also linear time variant system. Now we'll do both linear and time invariant systems. Suppose given a system y equal to n into x of n and they are asked to find whether this is linear time invariant or not. Find whether the system is linear system or an time invariant system or not. So as I already mentioned in the previous video, that to confirm whether it is a linear or non-linear, we'll apply the transformations. So consider first input be a times x1 of n and multiplied by n, we get a n x1 of n. Now second signal to be x2 of n into n b n x2 of n. So now add both the signals, both the input signals, and apply the transformation. We get na x1 of n plus nb x2 of n, where this is y1, where this is y2, this will be y3, and y3 equal to y1 plus y2. So this system is a linear system. Linear system. Now next we need to see whether it is a time variant system or time invariant system. So by looking at it, we can say that it will not be a time invariant system, it will be a time variant system, because one trick to say this is, whenever there is a multiplication of t, whenever there is a factor multiplied with t or n with the time period, then such type of systems will always be time variant systems. Now we'll see how it goes. Now first thing we need to do is x of n multiplied by n. We get y of n is equal to 1 of n into x of n. Now we are shifting the input by k time units, so we get this y of n comma k is equal to n into x of n minus k. Now in the next thing we shift the output by k time units, then this will be n minus k times x of n minus k. This is 1 and this is 2. By clearly 1 and 2, we can say that 1 is not equal to 2. So it is a time variant system. The system is linear but time variant system. So overall, the given system y of n is equal to x of n into x of n is a linear time variant system. That's all for this video. Thank you.